Hello everyone, welcome back to my let me share this. Hello everyone, welcome back to my YouTube channel Code Tricks. So today we'll be taking some Python challenges to help improve our problem solving skills with Python by taking just 15 exercises and looking at all these challenges and how we can solve it. So the number one challenge we have in our list here is finding the max of two numbers. And how do we find the max of two numbers here? Now let's say we have this function here called max of 2. Now we are going to return the max of the max between those two numbers here. So let's just say we have the f, okay, max of 2 now. Then we have two parameters, which is a and b. So what we want to do now is, the first thing we want to check if a is greater than b, right? If a is greater than b now, that means a is what? That means a is the max then. Let's just have a max set to 0 by default. Then if a is greater than b, we want to set this max equals to a. Then otherwise, if a is not greater than b, that means b is greater than a. We want to set max equals to b. Then let's just print out this after this operation. I want to print out the max of a and b is max, right? So we can do it this way now, and let's try and run this function here and see what we have. So trying to run this function, I will just call the function max of 2, right? And we give it any two parameters, which is a and b, to work with. So let's try and give it 1 and 2 first, and let's copy this and paste it a couple of times. Okay, that's okay. So let's have 12 here, and let's have 24. Let's have 51 here, and let's have 72. Let's have 13, and let's have 12, and let's have 109, 109, and let's have 209. So if you should run this now, we are meant to get the max of all these numbers. So running this now, we can see the max of 1 and 2 is 2. The max of 12 and 24 is 24, and the max of 51 and 52 is 72. Then 13 and 12 is 13. 109 and 209 is 209. So this is how you find the max of numbers, right? So and you can just go through the code and say again, this is how we find the maximum of two numbers. We first check if a is greater than b. Then if a is greater than b, we set the max as a. Then otherwise, if a is not greater than b, that means what? B is greater than a. So we set the max as what? B. So let's go to the second challenge here. So the second challenge here is to find the length of a string, right? So we are going to have a function here called string length, right? So I want to have a string input by user or by the function. I want to find the length of this string. So how do you find the length of a string now? So what we first want to do, we want to have a variable called count, and this is going to help us count how many letters or characters we have in this string. And now let's say, okay, we want to just loop through this string for I in S. So now we're looping through every single character in that string for I in S, and after every loop, what do we want to do? We want to add 1 to the count. That's count plus equal 1. And at the end, we want to print out the length of this string. The length of this string is, let's just print out our count then. So this is what we want to simply do at the end. And now let's test this and see. Okay, let's say string length, and we have, okay, let's say we have Andrew, we have string length, we have Trex. Okay, let me just copy this a copy of time also, and okay, now let's have, okay, I love coding. I am going to the market. Okay, and let's have mom is cooking, and my dad is reading the newspaper. Okay, so my dad is reading the newspaper. So let's test all this now. Now we're getting the length of Andrew now, which you all know is 6, right? It's telling us the length of these variables one by after the other. So now we have Andrew is what? 6, Drex is 4, I love coding is this, right? And okay, now we can see how it works, and this is exactly the way it is. So we could just put this in quotation and run this again. Now we get that specific string itself in quotation, right? So this is how you find the length of a string itself. So let's go to the next challenge now. Okay, challenge 3. So now I want to check if a letter is a vowel letter. So how do we check if a letter is a vowel letter? Let's just define our function here and call it is vowel. And this vowel, we just have this as C, and we want to define a variable here called vowel. Let me just call it vowel letters actually. And we have these vowel letters here, which is A, E, I, O, U, right? So what we simply want to check if E, this character, is in this vowel letter. So we want to check if C dot lower, and why we're using this lower is just for precaution. In case this function, a capital letter A, is passing through this function, is going to return false actually, because there is no capital letter A here. So we want to make sure that every capital that is passing through this function is converted to lowercase before we check if it is in this vowel letter. So we check if it is in vowel letters. So if it is in vowel letters, what do we want to do? Just want to print out. Let's just print. Okay. Let's print. Okay, let's have a formatted string here too. C is a vowel letter. And otherwise, so we are going to have else here now. Else, if it is not in these vowel letters that we have defined, what do we want to print out? We want to print out C is not a vowel letter. And if it's not a vowel, that means it is what? It is consonant. So let's test this by just using its vowel, and let's test this with capital letter A. Okay, let me copy this now and paste it a couple of times. Okay, let's have C. Let's have small letter A. Let's have B. Then we have R. Let's have I here, and let's have let me have L instead, and let's put this in quotation too. Let me make this double quotes instead. So I like to put this in quotation then. Okay, let's run this now. Now we're getting this. A is a vowel letter, C is not a vowel letter. Okay, there should be a quotation here also. So our code will be consistent. A is a vowel letter, C is not a vowel letter, A is a vowel letter, B is not, R is not, I is a vowel letter, and L is not a vowel letter. So this is how you check if a letter is a vowel letter. So let's move to the next challenge, which is challenge 4. So now we have to generate a string of characters that return a string of length consisting of only let me say this, only the character C. Okay, so how do we go about this now? What this place is actually telling us to do now is to return a string of characters that contain only the number C. So like this will be the character, this will be the character, why this will be the numbers of times we want this character to be repeated, to appear, and it will be given to us as a string. So it's generating a character as a string. So if this was actually to be C and this was to be 5, so we get C to appear 5 times. So how do we do this? So when we do this now, let's just have def generate and characters here. We have C. Okay, I'll just have a list here, an empty list here now. So what I want to do is now is for I in range n. Now for I in range n, what do I want to do here? So I want to loop through this n in range now, and I want to add to this my list dot append C. I want to append C to this my list, and what do I want to do? I want to say okay, string, can just say text now is equals to what? Okay, this does join list, right? So, and let's print out text. Okay, let's print out text here. So let's text this and see what we get. Okay, so generate and shows. So let's have 4. Let's and let's copy this now. We have 8 here, and let's have B. So we have 3 here, and we have okay A. And okay, last but not the least, we have 10 here, and we have C. So let's run this now. So we are seeing that we are getting these are now 4 times now, right? 1, 2, 3, 4. B is appearing 8 times here, and A is appearing 3 times, right? And 10 is appearing 10 times. Z is appearing 10 times, sorry. So this is how we get it actually, and this is what we do. But there's an easier way to do this in Python, and most of these challenges are easier way to do them with just calling some function, but it's very good for you to like try solving them yourself. You might not need to use this in a real world problem, but it helps you to know how it works and the logic behind it, which is greatly going to improve your problem solving skills as a whole. So you could just have 5, then multiply by t here now. So let me just comment this out for the sake of that. And if I should run this now, you see I'm getting this 5 times. So this actually worked well too. So we uncomment this and okay, comment this out now. So this is how you generate, and just go through the code and make sure you can do it. So let's go for number 5 now. So now we want to print the max of 3 numbers. Previously we've tried printing the max of 2 numbers, right? But now we're having 3 numbers, and how do we print the max of 3 numbers? So to work with max of 3 numbers here, what we need to do here now is, let me first define our function. That's max of 3. That's A, B, and C, right? So now if you want to print the max of 3 numbers here, what we need to do here is now like, okay, firstly we want to check if, okay, let's have our max first. Max equals to 0. And firstly we want to check if now, so we want to check if A now is greater than B, right? And A is greater than C. So if possible A now is greater than B and greater than C, then we know the max is equals to what? A, right? Then elif now, if A is not greater than B and A is not greater than C, what do we want to do? Okay, I'll give you a second to try think about that now. So what do you think we are going to be doing if A is not greater than, I mean, if A is not greater than B and A is not greater than C? Okay, what we'll be trying to do here now is, if A is not greater than C and is not greater than B, we want to also check another condition. And what would that condition be? That means if A is not greater than B, right? That means is either B is greater than A or C is greater than A. So we want to check if B is greater than what? C. So now if B is greater than C, and we already know from here that, okay, so I want to check if B is greater than A now. Oh, okay. So I want to check if B is greater than A. And if B is greater than A now, what is going to tell us that, okay, there's possibility that the max is what? And B is greater than what? C. So let's check this now. So if B is greater than A and B is greater than C, there's possibility that, okay, now the max is equal to what? B. So if A is not greater than B, A is not greater than C, B is not greater than A, B is not greater than C, then the mass should be what? C, right? So let's test this code and see if it's okay. If not, we adjust it. And okay, let me just copy this now, and okay, for now let's just print out the max. So let's have 5, we have 8, and we have, okay, now we are getting the max, right? The max says 3, the max says 5, the max says 8, the max says 12, right? So now so that this work quite alright, so we just stay and put this function here. See, the max of A, B, C is max, right? So running this again, so we get this now, we understand how this work well. So this is how we do it. Actually, there's another function in Python that you could use to do this, which is just by, okay, print max 1, 2, 3, and this will actually give the results out to you. So let me put this on comment and let's run this. Okay, so there is, okay, built-in, that is not subscribe skippable. Okay, this is meant to be a tuple. So yeah, I now get the max of this, and if I should change this to 33, I'll be getting the max, right? So you can see all this is just one line, but it's good you know how this works behind the scene, just to help improve your problem solving skills and your thinking ability when it comes to solving a life problem. So let's go to sum or multiplication of a number in a list. So that would be, okay, now sum and multiplication of numbers in a list. Now write a function sum and multiplication of list, right, that returns the sum and multiplication of all the numbers. So now, okay, this involves iterating a list, calculate both the sum and the product of the elements. It demonstrates the use of loops and basic arithmetic. So now what we want to do now is, now we want to have, right, a sum of number. We want to loop through these numbers and we want to calculate the sum of every single thing in that list, right? So we are going to have def sum. Okay, let me just say sum list, and this is going to take in a list as an argument. So we have sum set to 0 by default, and by now we want to loop through this list. For I in list, okay, sorry, this is for I in list. Now what do we want to do? So whenever we look through this list, we want to like, okay, for I in list now, we want to get this I, want to add it to the sum, right? Then when we are through with this list now, okay, we want to print out this sum, right? So let's see. So let's cover this list one. 1, 2, 3. So if you're getting 6 in return here, so if I shall call this function sum list one here. So if we should run this now, okay. So this is giving us back 0. So it's meant to be sum plus equal 1. Yeah, plus equal I actually. Now we are getting 6, right? And this is how it was basically. So let's just have more list here. So I just copy this now and let's have list 2, list 2, list 3, list 4, list 5, right? And I just increase this, then okay. So 2, 3, 4, 5. So now we get the sum of all these things here. So this is how we actually work with the sum, but you could just do something like this. It's a function also. So we have print sum here, list 1, and we have this. So I could run this now and yeah, we get the sum, right? And if this was to be list 2, normally when we run it before it was 24, now we see this is still 24. So that's how it works like that. So let's say now I wanted to have multiplication instead of sum now. I could just copy this now and okay, and call this so let's call this more, and this will be 1 and not 0, and this will be asterisk here. So 1 times 2 times 3 now will be 6 also. So let me just copy this also and so we have more here on list and okay. So let's see this now. So now we see that we are getting the multiplication of all this. So this is how that worked too. So let's go to challenge 7 now. So challenge 7 now, we have to check if this list is sorted, right? So now we want to know if a particular list is in the right order, either descending or ascending order. What we just want to check is to know if the particular list is sorted. So to check this out now, let's start by defining our function. Okay, def is sorted, and we have our list. So we want to have two variables here to know if this thing is ascending or descending, and by initially we set these true variables to true. And now we want to go for I in range. For I in range, the length of the list. And we want to subtract 1 because Python use zero-based indexing, which means it is starting from, okay, let me have an example of a list here actually. Okay, let me just have list 1 here. 1, 2, 3, 4. So we have 4 elements in this list now, but this is known as index 0, 1, 2, 3. So because of that, that's why we're using this -1 here. Because when you get the length now, it's going to tell us it is 4. But we want to look through each index. So we have to make sure we're subtracting 1 to that. It's stopping at index 3. So when we look through this, the length of this index, what we want to do is we want to check if the length of this list now is greater than, I want to check if the index before is greater than the index after, and that's just by doing this. Okay, I plus 1. So when I is equals to 0, when it's looping through the first index now, it's getting 1, right? So I want to check, right, if 1 now is greater than this. If 1 is greater than this, that means it is not in ascending order, right? So we want to set this ascend in order to false. So that's how we are going to check this. If, okay, now when it's not on index 1, it will be checking this index, right? Because this is index 1. Then 1 plus 1, that's index 2. So it's checking if 2 is greater than 3. If it is, that means it is in ascending order. So we have for I in range. Okay, for I in range, then list -1. So then now we want to check if this list I is less than 1. List I plus 1. Okay, let's see. So if it is less than this, so we want to set this and then equals to what? False, right? So yes, we want to do it this way. So either way, okay, if it's in ascending or it's descending, I want to print out the list is sorted. So we want to print out the list is sorted, right? So this, now we know that like with this we will know whether the list is sorted or not. So let's just start something like this. And okay, let me have more of these. So 3, 4, 5, 6, and I like to have this as 22, making that not sorted and this not sorted too, and 11, and let's have this reverse. So now if you should check this is sorted, list 1 is sorted, list 2. So we could just copy this now and paste it quite a number of times. So I'd like to change this to 3, 4, 5, 6, right? So I think that's all. So let's check this out. So now you are getting 3 lists sorted. So just to avoid confusion, let's run this one after the other. Okay, yes, this is sorted out, but if we should run the second one after this, yes, this is not sorted. Then let's have else. Okay, let's have a formatted string here and let's have the list here itself. And let's copy this. So when we have this here, we just okay. It's not sorted. So let me uncomment all this. So now we could get from here that's okay. This is sorted, this is not sorted, this is sorted. I can say this is coming backward, this is not sorted, this is sorted, and this is not sorted. So this is how you check if a list is sorted or not. So now let's move to the next challenge. 0, 8. So now we want to reverse a string. So we want to define a function that is going to compute the reversal of a string. So let's have the reverse. Okay, then we have the string here. And now what do you want to do? We want to have new equals to a new list. And for I in range, length of this, okay, let me change it back to x because in the comment here I put an x. Range x. Now, what do you want to do? Now I want to take this thing from the back. So this is like we are starting from the backward in this loop. So I can just like so let me try printing I here so you understand what I'm doing. So if I should say okay, reverse Andrew. So you're getting the index backward, as you can see. So this is what we're actually doing here. We get the length. The length is 6, right? But based on 0 base indexing, the index will be given to us backward. So we want to append every element, every character in that index. We want to append it to the string. And now that we are getting the index backward, which means it will be appended to this list backward. So So now when we append this, all we can just do is print, and let's join this together using the string join. So we want to join everything here together. So you can also print out this so that you can see how it goes. So we can print out new here and print out the joined version of this. So let's see. And you can see that we append this backwardly and now we have it this way, right? So this is just like us doing this. And okay, let me just say okay, let's have I am coding, I am cooking, Okay, run, run, run. Now we get this here, right? This is Andrew. Turn backward is Andrew. You see, just like this, and this is how it works. So this is how you reverse with Python. So let's go to the next challenge, which is challenge 9. Now, talking about 9 now, we have to define a function called is palindrome that recognize palindromes. What is palindromes actually? This challenge is just for us to check the word and if the word is the same thing when it is read backward. And it's just to compare if the word is the same when like read that same word backward. Just like as we have tested here before, what we want to check if this word is read backward, can it still be the same thing? So let's go back to challenge 8 here and let's just get to this function. We'll move the needing it, but could come quite handy. So let's have this here and let's have def palindrome is palindrome. So we have this is palindrome here and we have this S string, right? So but before that, I want to show you one thing. We can also just do this by just using this method in Python. You can say, let's say print out Andrew. But now, while printing out Andrew, I want to use this. Okay, let's see this. And you can see you're getting Andrew backward, right? This is just same way you can do this. We're trying to do it this way, just like now you can see you're using join, you're using a list, you're using append, make it to know more things and more functions you can use in Python actually. So I'm just going to go ahead and use this, or you can go ahead and try using this reverse to check if it's actually equal. So if you're using this reverse now, what you're just going to do is, let me comment this out, and instead of printing here, we just return instead. We return this, right? And what we want to check is, okay, then we call this function here and we just call, okay, reverse, then we put in S inside. Then now we want to check if reverse is actually equals to S. If they are equal, then we want to print out this is a palindrome. So yes, if it is actually equal, we want to print it out, then else. So let's just have this our formatted string here. So let's here. So it's not a palindrome. So yes, we want to print it out this way. So let me just have this function here. Okay, is palindrome. Can you think of any letter that is palindrome? Andrew is not. Okay, let's see. We have radar. Radar is actually palindrome, and okay. Now we can see that Andrew is not palindrome, radar is palindrome. And why do we say radar is palindrome? The reason is if you print out radar, just here, okay, instead of I'm just uncomment this and put radar here. You see that right here? We are getting back reader, right? We are putting it backward, but we are still getting reader. So this is how you work with it, like that. So that's how you can check if a letter is actually equal by printing it backward. You can use reverse, or you can use this other way, because I didn't do that. That's just like S minus 1 equal S, right? So you see we are getting the same thing, right? So these two functions work, these two ways work quite alright. So let's go to challenge 10. So now we have to write a function that filter out words that is longer than n. Then return the list of the words longer than n. Wow. So let's have a function here now. We call it the filter long words. Then we have the words here. This will be a list of the words. So we could easily do this with just using the len function. But first we have to loop through this word. Okay, so now we loop through I in words. Then if the length of I is greater than n, okay, I want to have a list here. If the length of I is greater than n, you want to append this to this list. N dot append I. So it will be list dot append actually. List dot append I. Then all they want to do, want to print out list. So okay, let's have filter long words. And just have fruits actually. Apple, lemon. Okay, then we have, let's have mango. Let's have should have fruits. Okay. Okay. Let's have pineapple. Want something long. Okay, let's have that. And now, okay. Now we want to put in these fruits, and we want to fit out the numbers that are longer than 5, right? We have 2 longer than 5, and we have others that are no longer than 5. So let's print this out. Now we're getting banana and pineapple back, right? That's because they are longer than 5. But if I should put in 3 here, we are getting back just the full list again, because they are all longer than 5. And these are it. Okay, if I should put in 6 now, I'll be getting back just pineapple. And if I should put in 9, I'm still getting back just pineapple. But 90, yeah, getting back an empty list. So that's how it is. And this is how you like print out. So print out the words that are longer than an integer in a list. So let's go to 11. So now we have to count the vowels in a string. So now we have to create a variable here now. A function called the count vowels. And how do we do this? We have s here, right? And we have to count these vowels in the string. So how do we go about counting these vowels and having these vowels counted? So what we want to do is, for I in that string, let's have our vowels A I O U. So Then we have count. Then now I want to say for I in S. So for I in the string, I want to check if I in vowel. If I is in the list and I is also in vowel, when I'm looking through each character in that list, I want to check if that character is in vowel. I want to add 1 to that count. Count plus equal 1, right? Then what do you want to do? I just return. Let's return count. So we say, okay, let's say print count vowels. Okay, what I want to do is for I in list, if I dot lower, okay. So let's copy this, paste it a couple of times. So I want to have dress, and in dress we only have one vowel. And let's have Paul. Let's have boy. Okay, this is just one vowel. Have bread. So okay, come in. So now we can see, okay, let me just add this way. Let's return this way. There are vowels in S. So we have 2 vowels in Andrew, 1 vowel in Drex, 2 in Paul. There are A and U, 1 in boy, 2 in bread. So this is how you count the vowel letters in the word. So let's go to the 12th one, challenge 12. So now we have to convert binary to decimal. So how do we convert binary to decimal? So how do we convert binary to decimal, and how do we go about this? So to convert binary to decimal, what we need to do now is, okay, let's have our function binary to decimal, right? And we have binary. Okay, now we have the binary function, right? So we're going to have 2 variables here, and one is going to be binary and the other is going to be decimal. Sorry. So one is going to be like decimal, then we have, okay, let's call this I. I want to initially set both of them to 0. So when we set this 2 of them to 0, what we want to check is why binary is not equals to 0, because we want to constantly reduce from this binary, take out from this binary. Why it is not equals to 0? Okay, let's just enclose this in bracket. Why binary is not equal to 0? What do we want to do? So we want to divide this binary we have, like modulus sign division, by 10. That means we only want to get the remainder, right? So if you remember how we do convert binary in school, those, yes. So we just want to have another variable here. I want to call it dec. I want to divide this binary by 10, but we only want to get the remainder. That's why I'm using the modulo sign. We only want to get the remainder. Then this decimal now will now be equals to what? Decimal, former decimal now plus dec, which is the remainder of this, then multiply by the power of 2, which that just like 2 raised to power I, and right now our I is 0, right? So then after we do this, we want to have an increment with our I. Okay, no thanks. Okay, after we do this, we want to have a binary now. We want to divide it by 10. And we're using this two division so to give us an accurate integer. We don't want a float, we don't want a decimal. So then after that, we want to have an increment with our I. So that's I plus equal 1. So after all this, we want to return our decimal. So return decimal. So print. Okay, what do you do now? We print out. Okay, binary to decimal. Let's have 10. Okay. Okay, let's have 10. Okay, let's start from 1. Okay, 1, we have 10, then we have 11, 100, another 1, 0. Okay, 1,000. So let's have this way and stuff. So let's get this and okay. Let me have a formatted string here also. So okay, let's have the binary here. Okay. Okay. Okay, let's have the binary here. Okay, I would like to call this okay to decimal is. So let's try this out and see. Okay. Okay, I forgot to close this quotation. Yeah, it's giving us 0. That's because we are removing this binary each time. So let's just have this as decimal. So now, looking at this actually, this is actually 1 and 2, 3, 4, 5, 6. And we see we are getting back the decimal value of all this. So this is how we convert from binary to decimal. So let's go to 13. No, we've been writing some maximum. Okay, so now we have to write maximum in a list actually, and now we'll be using some functions to make this easier and faster. So we have to write the max of some letters in the list now. So just say def max in list. So want to have max set to 0. Then now want to say for I in range, length of that list now. Then I want to subtract 1 there because of 0 base indexing. Then now I want to check if list I is greater than list I plus 1 and list I is greater than max, right? So I want to check it like this. So if the first index is greater than the second index and the first index is greater than the max, what do we want to do? Then in this condition, we want to set the max to be set to what? It's with the index of I. Then else as elif, want to set lists to be set to, okay, now else want to check if plus 1 is greater than max. Then we want to set the max to be what? List I plus 1. So let's just print out max. So let's test this function and I just, okay, max in list 1, 2, 3. So I'll copy this and paste it a couple of times. So let's run this. Okay. So now we are getting the max of each now. So now what we're using here is now, when we look through this list, we compare this index to this. If this is greater than this, and this is greater than the initial max number, we want to set the max to be this. But otherwise, that means this is greater than, then we want to check if this is greater than the max number, then we want to set it as the max number. Then we will now move forward now. We are now comparing this and this, then this and this, then this and this. So just like that is how we compare this and check things out. So let's go to 14. So I think we've done the longest word in a list before. Yeah, I think we've done this before. Let me see. Okay, not really. But okay, let's just say we have there find longest word as was. Find longest word as what now. All we want to do is for I, okay. Let's say max word now equals to 0. Then for I in words, when we look through this now, we look through this list for I in words now. Then I want to have for J in I itself. When we get the word for J in I. Okay, now we done this. Okay, so now I want to check if length of I is greater than max word. Then if length of I is greater than max word, I want to set max word equals to length of I, right? Yes. I want to set the max word to equal to the length of I. So write a function to return the length of the longest word in the list of words. So, and what we want to do is just print out max word. So let's run this print. Okay, I don't need to do that. Find longest word, apple, orange, okay. So let's copy this and Hush, Andrew, Tim, Paul, Max, okay, Matt, A, female, girl, boy, man, and woman. Okay, so now let's see. First one is telling us 6, that's orange, that's right. 6, that's Andrew, that's right. 4, Paul and Matt, that's right. Then female, that's 6, woman, and that's right. So let's go to the last one for today. So now we have to find Fibonacci sequence. So we have to write a function for Fibonacci sequence that return the first n numbers in the Fibonacci sequence. Okay, so we have to have a list of numbers according to what we want. This Fibonacci sequence is just like a list of number in which the addition of the previous two number will give us the number. So if we have 0 and 1 now, we have 1 next. So the addition of these two numbers now will give us 1. And if we should have 2 next, the addition of these two will give us this. So this is what it is about. So what we can just do here is now let's have our def Fibonacci. Then we have n. So we want to have Fibonacci sequence now. Sequence. So initially I want to set this to 0 and 1. Okay, this is meant to be a comma. Okay, why is set to 0 and 1? So y len fib sequence less than n. Then we have fib sequence minus 2. No. Okay. Why if the length of this fib sequence is still less than n? We want to have fib sequence dot append. Okay. Fib sequence minus 1 plus fib sequence minus 2. So what we're just doing here is, why this fifth sequence, the length of this list is still less than what we initially enter here. We want to add the last two, which is looking now. If we're dealing with 2 now, we want to add this minus 2 here, that's here, plus this, then we want to add it to the list, which is now 1 plus 1 equals to 2. So we want to add it like that, and now, okay. So what do we do? Let's just, okay, print out. So let's print out fifth sequence actually. So I just want to print out fifth sequence and from beginning to the end. So I just call this function and let's have 10. Okay, I will copy this. So 100, 13, 5. So let's run this. Wow, I think 100 is too much. Just comment these two big numbers. So now we have this 0 plus 1 will give us 1, 1 plus 1 will give us 2, 1 plus 2 will give us 3, 2 plus 3 will give us 5, 3 plus 5 will give us 8, 5 plus 8 will give us 13, and just like that. And now we have it just like that now. 21 plus this will give us 55. So this is how you work it. These are just some cool Python challenges you have. I hope you love them, and I'll leave the directory to the GitHub. I'll leave the GitHub directory in case you want to see the source code. I'll leave the source code to the GitHub directory right in the description with the challenges written out in the description too. Thank you very much for staying this far with us. See you next time.